Welcome to this tutorial on variables. So variables are a little bit different than anything we've dealt with so far. Instead of allowing us to manipulate stuff, variables allow us to remember stuff, or they allow the Arduino to remember stuff. So up until now, whenever we've been operating, everything that we've done has been based on what is happening right now. The Arduino had no way of recollecting what had happened in the past. By adding variables to our code or to our set of tools, we're now able to set things up in the past and have the Arduino recall them in the present. So there are a bunch of different kinds of variables that we can use. The two that we're going to focus on today are ints, which can store numbers between negative 32,768 and positive 32,767. And longs, which can store numbers from like negative 2 billion, roughly, to positive 2 billion. The difference between the two is that ints are shorter, obviously, and in being shorter, they also take up less memory within the Arduino. Longs are longer, and they take up more memory. There's a bunch of other different kinds of variables. There's floats, which can use decimal points, whereas ints and longs cannot use decimal points. They can only use whole numbers. There are bools. There's a whole bunch of different ones. For our purpose, we'll just focus on the int and the long. I would recommend that if you need something else, or if you find that the int and the long aren't satisfying your needs in terms of the code you're trying to write, then you should go to the Arduino reference library and look up the other kinds of variables. To look at variables, we'll start with the most basic use, and that's to create something that defines a pin that will be used over and over again. This definition of the pin allows us to change it once instead of throughout the whole code. And it also makes the code a lot easier to read. So if we look here, we have set up an int, we've called it LED1, and we've told the Arduino that LED1 equals 0. You notice the difference between this equal sign and the equal sign used in something like an if statement is that there is only one equal sign here. And in that, we're telling the Arduino that LED1 equals 0. We're not asking if it equals 0, we're telling it that it equals 0. Now we've told the Arduino that LED1 equals 0. We've also told the Arduino that we've created another int. We're calling it LED14, and it equals 13. So LED14 equals 13 because this, if we were calling LED1 0, then LED14, which is the 14th LED along here, is going to equal 13. We're also telling it that button 1 equals A4. Now, the purpose of this is twofold, as I mentioned earlier. The first is that it makes the code a lot easier to read, rather than having to recall what pin 1 is attached to. Now, in this case, because there's just 14 LEDs and 2 buttons, it's quite easy to remember what's attached to what. But in more complex situations, you might have like 14 different things plugged into each pin, and it's much harder to remember what's plugged into what. So here, it makes the code much easier to read, because I know that LED 1 is now being set to an output, rather than having to recall what 1 is attached to. And the second reason is so that we can change it across the whole sketch. So I've used LED14 here, and I've used LED14 here. Now say I wanted to switch from this LED being lit up to this LED being lit up. Now if I just used numbers, I would have to change it twice. I would have to change it here, and I would have to change it here. But because I used a variable, instead of changing it twice, I can just change it once here. So rather than having pin 13 light up, perhaps we will have pin 10 light up. Now, just to make sure that it's clear, just like in the digital read, where the digital read replaced itself with whatever reading it got off the pin, the same thing is happening here with these variables. What the Arduino is actually seeing here is the number 10. It's taking out this LED14 and replacing it with 10. So just as a note, if you are defining the A pins or the analog pins, it's important to define them properly. So in this case, you need to have a capital A and not a lowercase a. And just to satisfy everyone's curiosity, because I know everyone's just unbelievably curious about how this is going to work, we'll run the simulation, even though this is basically the same as the code that we had in the last tutorial. All we've done is replace the numbers here with variables, and it'll run exactly the same. So we start the simulation. It runs exactly the same. If we press button A4, the LED turns on, just like it would have happened if we'd used numbers instead of the variables throughout. Okay, so let's take a look at how to solve some coding problems, or more complex coding problems with variables. And I think what I'd like to do is try and solve a blinking problem, except this time I'm not going to use the command delay in the final solution. So a good way that I find to approach more complex coding problems, or problems that I'm having a problem figuring out how to solve, with just code, is to write out the problem in plain English and then sort of work it through bit by bit until I can start figuring out where the code actually fits in. And so what I want to happen is light to come on, wait for 1 second, light turns off, wait for 1 second. We should be familiar with that. That's sort of what we saw in one of the first challenges that we did. So this is all well and good, but it's obviously not Arduino code. So the next step is to think about how we can start translating this into Arduino code. And the first thing that's kind of useful to do is to think about ways that we might be able to streamline this. So right now we have 4 lines of code. We might think, okay, how can we do this more efficiently? And one way to do it more efficiently is to, keeping in mind that we are in the void loop here, wait for 1 second, and then switch the state of the LED. Now we've taken what was once 4 lines of code to only 2 lines of code. What I mean by switch the state of the LED is if the state of the LED is on, then it'll switch it to off. And if the state of the LED is off, then we'll switch it to on. Now we've broken our code down into 2 manageable problems, right? So we have 1, we need to figure out how to wait for 1 second, and 2, we need to switch the state of the LED. So let's start off by taking a look at how to wait for 1 second. So we can start off by moving it a little bit more towards Arduino code. We can write something like this: if 1 second has passed, switch the state of the LED. Right? So that's starting to look more like Arduino code, but now we need to solve this problem here. How do we know if 1 second has elapsed or 1 second has passed? Well, if we think about time and how we figure out how much time has passed, we can think, okay, well, if I started doing something at 0 minutes and it's now 63 minutes, how do I find out how much time has passed? Well, I go 63 minus 0, and I find out that I have been working on something for 63 minutes. If, on the other hand, I start doing something at the 5-minute mark, and it's now the 25-minute mark, I know that 20 minutes have elapsed. So we can do something similar up here. So we can think, okay, if current time minus last time the LED switched, and we can use shorthand, so last time the LED switched is greater than, let's say, 1 second, so 100 milliseconds, because the Arduino works in milliseconds. And then we're going to switch the state of the LED. So this raises the question of, how do we know what time it is? And the answer is the Arduino uses a command called millis, and it looks like this, M-I-L-L-I-S, and it'll turn orange, to count from the time it turned on until the time it turns off. It counts in milliseconds from starting at 0 all the way up to 10,000, 100,000, a million, 10 million, 100 million, a billion, 2 billion. It'll just keep counting 1 millisecond at a time, and it'll record that. So if we want to know how long it's been since the Arduino was turned on, we can call on millis, and it will tell us exactly how long it has passed. So over here, we might say if millis minus last time is greater than 1,000, switch the state of the LED. Which then raises the question, how do we know the last time that the LED switched its state? Now, because we've been paying so much attention, we will recall at the beginning of the video, I said that one of the good uses of variables is recalling things in the past. So if we come in here and we think, how are we going to get the Arduino to remember the last time something happened at this point of the code? Well, the easy answer is we're going to make a variable. We're going to call it last time so that it's consistent with here. We don't have to change anything. And we'll say it equals to millis. And now the Arduino is going to know here, every time it gets to this point, it's going to remember when it did this thing right here. Now I know that this code is happening before this thing, but it's important to remember that the Arduino moves so quickly that the difference in time between this line of code and this line of code, or these 6 or 7 lines of code that it's going to end up being, is really, really small. We could move this down below, but it doesn't really matter. This is happening so fast, it's happening faster than milliseconds, it's not really a concern. So now we're here, we can start moving over into the Arduino IDE. This here is starting to make a good amount of sense. It's pretty much looking like Arduino code, so we can come over here and we can start typing it out. Recall that we're going to write in the void loop because it's going to happen over and over again. So let's try it out. If millis minus last time is greater than 1,000, we want it to do something. The first thing we want it to do is remember that it's about to switch the state of the LEDs. So we'll say last time equals millis. And then we kind of want to know if this works. Is this going to do what we want it to do? We don't really want to solve this part of the code yet. We just want to double check that this works. So there's a couple things that we can do. The first thing I would do, and this is mostly just because it makes things look nicer, but it'll also pick up on some basic mistakes, is come up to Tools and go to Auto Format. This will move everything around so that it's easier to look at. The second step is we can hit this check mark and see if the Arduino will compile the code. And that means it's going to try and check it for any kind of goofy errors that we did. It won't make sure it works because it doesn't know what we're trying to accomplish, but it will check it for any kinds of like syntax errors. So if we missed a semicolon or missed a bracket or put a bracket in the wrong place, etc. It's going to ask us to save it. You don't really have to save it. You can just exit out and it'll still compile. It's compiling, it's telling us a problem. So it's telling us right down here that last time was not declared in the scope. Now recall that whenever we create a new variable, we need to start by telling the Arduino that it exists and telling it what kind of variable it is. There is longs and ints and chars and bools, etc. There's a bunch of different ones. Now the question is, where do we want to put it? Something important to know is that when we declare a variable, we need to give it a value. So if we put our last time variable here in the void loop and said it was equal to whatever, we should give it a value, 0. Every time that the Arduino loops or goes through the void loop, it's going to reset in last time to 0. And since we're trying to remember when the last time we were here is, it doesn't really work. So instead what we're going to do is we're going to place it up outside of the void setup. Now we have this int will be declared one time at the very beginning when the Arduino just starts up, and in here we don't have to worry about it. So let's compile the code again, exit out of that, and see what happens. This time, as you can see, it did compile nicely. Now there's no real way to check this code to see if it works because nothing is actually being done. Right? Nothing will be exported or seen when we simulate it. But what we can do is come into Tinkercad and we can check to see what's happening. Now, if we run this simulation, it'll run, but you can't really see anything happening. What we can do is we can come into this debug menu here and we can put a pause right here. And then what we should see is if we look up here, every 1 second or 1 second plus a millisecond, we will see it pausing here. So if we continue, we'll wait for 1 more second, and it's paused. So at least we know now that the Arduino is entering this if statement once every second. We could double check our code to see if our logic is making sense by switching this to 500. Now we should expect to see the Arduino pause at every half second. 501, it's paused. 1 second and 2 milliseconds, it's paused. So we know now that this part is working. Even though this works, there is a bit of a problem with it, and that's that we've used an int. An int will only store up to 32,000 digits. If you think that 1 second is 1,000 milliseconds, 32,000 milliseconds only equals 32 seconds. So after 32 seconds, this code isn't going to work very well. The solution to this is to use Au-Lange. Au-Lange will store up to something like 2 billion plus digits, so that would allow us to run this code for much, much, much longer. The way that we set up Au-Lange is rather than writing int, we write long, and that's it. The code will run exactly the same, it'll just run for a lot longer. So I won't bore you or belabor this process by going through the same steps to write the rest of the code, but I've created the code and I'm going to explain how it works. So up here, I've declared the two variables that I'm using. I've had to add one for the LED state so that the Arduino can recall what the previous LED state is or know whether or not the LED is high or low. Down here, I've told it that pin 1 is an output, just as we've done in many of our other sketches. And down here, I've added these two lines of code to switch the state of the LED. So I'm telling the Arduino that the LED state is equal to the opposite, and that's what this symbol right here means, the opposite of itself. So if this is equal to high, it'll now equal to low. If this is equal to low, it'll now equal to high. This only works for something called booleans, which are essentially 1 or 0 or high or low. You couldn't use the exclamation point to find the opposite of many other things, but it does work in this case when we're just using high or low. It's telling it to switch. It comes down here and it digital writes 1, pin 1, to whatever the new LED state is. And when the code is running, it looks like this. I hope you found this tutorial helpful. If you have any comments or questions, feel free to leave them in the comment section and I will try and answer them. Good luck, and thanks for watching.